be the same as our equations, but we're going to have some different symbols here, right? We're going to have the greater than or the less than or greater than or equal to symbols instead of just an equal sign. And you're going to start by graphing a boundary line. And when you graph the boundary line, just imagine that there is an equal sign there. Okay, so we're going back to our idea of graphing a linear equation. We need to find a couple of points. This is in slope-intercept form, so I'm going to start at my y-intercept, which would be -1. And then I'm going to move with a slope of 3/1. So I'm going to go up 3 and over 1. Up 3 over 1. Give me a few different points here. I could go down 3 and backwards 1. Also puts me on that boundary line. Now, interestingly, if there was an equal sign there, I would draw a solid line. Now, in this case, I just have a less than symbol, so I don't want it to be equal. And to show that it's not equal, I'm going to make a dashed line for the boundary. So I'm going to connect these points that were the equal to, that are not technically solutions to my inequality because I'm only going to be less than. And what that boundary line does is it splits that coordinate plane into 2 halves. And 1/2 is going to be my solutions and 1/2 is not. And I need to shade in the side that is my solutions. Let's do blue. Now to pick the right side, I'm going to test out a point. So for instance, the easiest one to pick is going to be the origin, which is there on the left side of my boundary line. And if I test that point out, meaning I check to see if it's a solution, right? So if I'm testing 0, 0 on this side of the line, I'm going to put 0 in for y and a 0 in for x into my inequality, and I'm going to see if that makes a true statement. So is 0 less than 0 minus 1 negative 1? This is not true, meaning this point right there is not a solution. At that point, if I find a no, I know I'm going to shade in the other side. But we could also prove it. So let's just say this is my solution set over on this side of the boundary line. Let's prove that it actually is, right? I can pick any point over here. So let's try the point. Oh, just anything. What's this one? This would be 2, 0. Right, so I'm going to test that in. That means the y is 0. Is 0 less than 3 times 2 minus 1? Is 0 less than 6 minus 1, 5? This comes out a yes, right? And any coordinate pair that I pick on that side will be a yes. So the shading, right? Shade the solutions. And if you find one, you found all of them. And if you find a no, you know it's just the other side. The shaded side will represent the solutions. And if it happened to be an equal sign instead of a less than symbol, right? If it was less than or equal to, you would make a solid line. So let's just make a note over here, right? If we have less than, or greater than, those are your dashed lines. And if the symbol was greater than or equal to, or less than or equal to, right, had the little equal sign underneath, you want a solid line. And that's how we graph linear inequalities.